Gentlemen, may I have your attention, please? The show starts in 5, 4, 3, 2, 1, go!
Assalamualaikum warahmatullahi wabarakatuh. So in this video, we will be presenting about the process of back titration in analysis of the aspirin. So this is our group members. My name is Athilanur Manisha binti Jalaluddin. Next, we have Iman Nurizzati binti Muhammad Hatta, Nur Maisarah binti Hambali, Nur Batrisyia Alya binti Muhammad Azrin, and the last one is Kamalin Mastura binti Fauzi.
Hi, my name is Kamalin Mastura from Group 7, Part 4. So let's begin with what is back titration. Back titration is quantity of excess reagent is used to react with an unknown substance to estimate its reagent. So this requires two steps reaction with two balanced chemical equation. Reactant A with unknown concentration reacted with excess reagent B with known concentration. Then direct titration is performed to determine the amount of excess reactant. So the objective for this experiment is to determine the amount of acetylsalicylic acid in aspirin and to determine the unknown concentration of an identified analyte in a sample.
Hi, I'm Batricia and I'll be explaining about the theory of this analysis. Acetylsalicylic acid, often known as aspirin, is a drug used to treat fever and short-term discomfort. It has been marketed as a painkiller for a variety of illnesses. Aspirin comes in various strengths according to how much acetylsalicylic acid is present. The quantitative method of titration will be used in this experiment to measure this quantity. Titration is a method for determining the concentration of an unknown acid or base by adding the correct amount of one to neutralize the other. So, when an acid and a base combine to generate water and salt, this process is known as neutralization or an acid-base reaction. This is the balanced molecular equation for the reaction between sodium hydroxide and acetylsalicylic acid. So in order to ascertain the quantity of acetylsalicylic acid present in a sample, it is necessary to have accurate information about the volume and concentration of sodium hydroxide used, as well as understanding the complete reaction involved. Since the concentration of sodium hydroxide can vary over time, it is considered as a secondary standard. And to determine the exact concentration of sodium hydroxide, it needs to be titrated against a primary standard, which refers to an acid that completely dissolves in water, which in this case is the acetylsalicylic acid.
Next, let's continue with the methodology. Before we proceed to the procedure part, there are some apparatus and materials that we will use in this experiment. First and foremost, of course, the material we will use is aspirin sample, as we know this experiment is about to analyze the aspirin. Next, 0.1 m of sodium hydroxide, hydrochloric acid, and phenolphthalein. For apparatus, we will use burette, pipette, conical flask, beakers, distilled water, and heating plate to complete this experiment. Next, for procedure, we will have 4 parts, which is the first one is preparation of aspirin solution. First, 0.25 gram of aspirin sample was weighed accurately and was transferred into a beaker. After that, a little distilled water was added to the beaker to dissolve the aspirin sample. Second part is acid hydrolysis. First, an excess of hydrochloric acid was added to the aspirin solution in the beaker. Then the mixture was heated gently to facilitate hydrolysis. The hydrolysis reaction converts acetylsalicylic acid to salicylic acid. Next, neutralization, where the first step is the mixture of hydrochloric acid and acetylsalicylic acid was allowed to cool to room temperature. 2 drops of phenolphthalein indicator were added, and then the mixture was titrated with sodium hydroxide solution to neutralize the excess acid until the indicator changed color, which indicating the endpoint of the neutralization reaction. For the last part, and as our main topic, which is back titration, firstly the neutralized solution was transferred from the beaker to a conical flask, and then 2 drops of phenolphthalein were added to the conical flask. After that, the conical flask was placed on white tile and the burette was filled with sodium hydroxide solution. The solution in the conical flask was titrated by adding the sodium hydroxide solution from the burette until the indicator changed color, which indicating the endpoint of the neutralization reaction. And lastly, the percentage of acetyl salicylic acid in aspirin sample was calculated.
Next, I will explain about the next part, which is calculation part. So for the calculation part, we have to determine the amount of acetyl salicylic acid in aspirin. So firstly, we have to state the balance equation for the reaction between acetyl salicylic acid and sodium hydroxide. So the equation is C9H8O4 plus sodium hydroxide, and the product is C9H7O4 and A plus H2O. So next, we have to determine the mass of sample, which is aspirin, equals to 0.25 gram, and the volume of sodium hydroxide that used in this experiment, we use 25 ml, and the molar mass of acetyl salicylic acid is 180 gram per mole. So next is mole of sodium hydroxide. To find the mole of sodium hydroxide, we have to know the molarity and the volume that used in this experiment. And the molarity for sodium hydroxide is 0.1 molar, and the volume we have to convert to liter, so it becomes 25 times 10 to the power of negative 3 liter, and the mole of sodium hydroxide is 0.0025 mole. Okay, after we have the mole of sodium hydroxide, we can compare with the acetyl salicylic acid to get the mole of acetyl salicylic acid. As we can see at the balance equation, we can see that 1 mole of acetyl salicylic acid is equal to 1 mole of sodium hydroxide. So the mole of sodium hydroxide is 0.0025 mole. Same goes to mole of acetyl salicylic acid. Next, we have to find the mass of acetyl salicylic acid. To find the mass of acetyl salicylic acid, we have to times the mole with the molar mass, so we can get 0.0025 mole times with 180 gram per mole, and the answer for mass is 0.45 gram. Next is percentage of acetyl salicylic acid in aspirin. So the mass of acetyl salicylic acid is 0.45 gram divided by 0.25 gram, which is the mass of sample, and we times with 100% to get the percentage, and the percentage is 180%. So we can see that there is some errors that occur in this experiment.
So let's proceed with the conclusion. In conclusion, the calculation performed on the aspirin sample indicates an approximate ASA content of 180%. However, it is important to note that obtaining a value above 100% indicates a potential error in the analysis. Such errors may arise due to the impurities, incomplete reactions, or inaccurate measurements. It is essential to address these potential sources of discrepancy in order to ensure the accuracy and reliability of the analysis results. Further investigation and validation are recommended to confirm the actual ASA content in the aspirin sample.
So this brings me to the end of our presentation.
As we can see in this slide, we included all the references that we used to get the information for the analysis. So that's all from us. Don't forget to click the like button and put your comment below. Thank you for watching.